What's up, everybody? Mr. Enyart here. Just stretching, checking out my shirt, teaching. It's a walk in the park. Get it? Thanks, Elijah, for the shirt. I love this thing, man. It's awesome, unique, individualized, creative, just like our morning work for Tuesday, week 30. Let's do it. All right, y'all. So here we are on week 30 Tuesday. Remember to watch week 30 Monday before this one. You'll get a little more in-depth details and explanations on these problems. And then each day I'll do a little bit less of an explanation, more of just a check with a few little tidbits here and there. So using a proportion is just a ratio between two equal amounts, but they are different units. And so the different units are different sizes, and so therefore the smaller units, in this case millimeters, are going to take a lot more to fill the same space as 1 meter. So 1 meter long is the same as 1,000 millimeters. And so when we have 7,463 millimeters, we're going to have a lot less meters because meters are a bigger unit and it will take less of them to fill the same space. So we're going to use this magic number 1,000, and they've got it set up like this. But basically what we're doing is we are dividing 7,463 by 1,000. Since we're dividing by a whole number, that's going to make our number smaller, and that's our goal. So when we divide by 1,000, remember there's an imaginary decimal right at the end of the number here. So 7,463, there would be a decimal here. We're going to move it to the left 1, 2, 3 times because we're dividing by 1 doesn't change it, and then we have 3 place values with those zeros. So it's 7 and 463 thousandths meters, or 7.463 meters. And again, here we are with milligrams and grams, and as you can see, milligrams are the smaller units because it takes so much more of them to equal 1 gram. And since we have our smaller unit, we're going to get to a bigger unit. Our number will shrink by 1,000, the exact same as it did before. So we're going to be dividing by 1,000 to find how many grams. And that will just be moving our decimal back 3 times, giving us 2 and 146 thousandths grams, or 2.146 grams. So I like these kinds of questions. What did he do wrong? Change my color too. So remember, MAD is the distance of each number from the mean. So in order to calculate the MAD, you first have to calculate the mean. So let's do that. So this would be 9, and this would be 19, which is going to be 28. And 28 divided by 4 is 7. So the mean, right, the average is 7, because remember the mean is to add them all up, then divide by how many there are. And so to find the MAD, we would then write a new list of numbers of how far is this 4 from 7? Well, it's 3. How far is the 5 from 7? It's 2. The 9 from 7 is 2, and the 10 from 7 is 3. So there's no way our MAD will be 7, because none of these numbers even get that high. But we basically have 5 plus 5, which is 10. And 10 divided by 4 is 2.5. So our MAD is 2.5. All right, and now to answer the final question, what did he do wrong? He only calculated what? Yep, he only calculated the mean. He did not do the extra step of finding the mean absolute deviation. And this is one of those typo thingies that, you know what, we really just can't do. I think you could just kind of skip this problem because there are no numbers here to relate to and use. I would say, though, that understanding IQR is interquartile range. And when we do interquartile range, I've got several videos on Edpuzzle and YouTube for just this thing, and using box plots, but basically we're going to be doing quartile 3 minus quartile 1 to find the distance, right? The distance between our quartiles from, so this would be quartile 1 and this would be quartile 3. And to find that distance, we just subtract the big one and the small one. But since we don't have numbers, go ahead and skip this question. All right, so I don't know why, I just love these kinds of questions. But whenever we're finding a percentage of something, remember percent, P-E-R-C-E-N-T, is just 90 out of 100, 90 hundredths. So I can use a model like a tape diagram, right? Cut it into 10 pieces, because if that's 90 out of 100, that's 9 out of 10. And 90% would be 9/10 right here, right? And we have to understand what it's asking, right? It says of x. So x has to be our whole, because what we don't know is we know that 90% is 36, but we don't know is what the total is. It's 90% of what? So x is our what? X is our whole, and 90% we line up with the number 36. So you can see that I have 9 equal rectangles that equal 36. So how could I figure out what each rectangle is? Aren't I breaking 36 into 9 pieces? Isn't that just 36 divided by 9? What's 36 divided by 9? 4. So if each box is 4, that means I have now 10 boxes of 4 to find my total, not 9. 9 was only 90%, right? 10 boxes of 4 would be my total, so what's 10 times 4? 40. So x would have to be 40. And of course, you could set this up algebraically by dividing 36 and 0.9, which is the decimal form of 90%. Now, I don't like dividing by decimals, right? So we make this 9. We add a 0 here, because we just moved that decimal over. 9 goes into 36 4 times, and then you've got your 0. So why would I divide? Because when you divide by a decimal, or a fraction, or a percent, your whole number gets bigger. When you multiply, it gets smaller. It works as the opposite of a whole number. So remember, the area of a triangle is base times height divided by 2, and the base is 10, the height is 3, so that's 30. Divided by 2 is 15 yards squared. Here again, 5 times 4 is 20, and 20 divided by 2 is 10, and our units are kilometers, and we're going to put squared because we're squaring them. All right, so we paid $75 for 15 shirts. How much did each shirt cost? So our idea is that we would have a model like this, right? So 15 shirts, each block could represent 15 shirt or one shirt. So this is 1 shirt, 2 shirts, 3 shirts, 4 shirts, 5, all the way to 15 shirts. But it also is a certain amount of dollars, right? This one shirt costs a certain amount of dollars. And since each one is equal, aren't we just taking our 75 and dividing it amongst the 15? And so 75 divided by 15 is our sentence here, number sentence. So how many 15s can go in there? Remember, we go time. 4 15s is 60. So one more would be 75. So each one has to be 5. Right? So $75 for 15 shirts. That means each shirt costs $5. All right, so 9 is kind of impossible for us to do on a computer screen because we can't measure the height. 7 is not the height. It isn't labeled next to a right angle or a side that is connected to the right angle. Remember, height is from the base to the top. That's how we would measure height, and the area of a parallelogram is just base times height. So we could say that 10 is our base, but 7 is at a slant. And remember, a slant is not the same as the line. If you were to shift it over to make it a right angle, it would be sticking up a little bit. This is a little longer than that straight edge would be. So the only thing I can really say is, since I know 10 times 7 is 70, I could say that my area is going to be less than 70 units squared. I can't say anything about the actual area, though. So finding the area of this parallelogram, I don't know, because we don't know what the height of this is. We're not given that, and we're not given the area in order to find a missing side. We're just given a base and a slant. So we do know that the height is less than 7, right? The height has to be less than 7. But we do not know what the actual height is. And so for number 10, we're just going to use our formula on the right to plug x in this case, -3 for the first one. All right, so we have -3 plus 1. So y would be -2. If we have -1 plus 1, y would be 0. If we had 1 plus 1, y would be 2. And 3 plus 1, y would be 4. I hope that was helpful. That's my eyeball. Cameras are fun.